My name is Rob Chiarelli. Today I will be presenting for you the bulk extractor visualizer, which is my final project for this course. I'm sure you all remember bulk extractor from the third homework assignment, but just as a refresher, what the software does is examine the contents of a disk image and produce a series of output files that contain the information found within the image, like credit card numbers, phone numbers, and email addresses. One thing I noticed while using this software was a number of files that we didn't use for the assignment, the histogram files. What these contain is a list of the items found within the file, one line per item, with the number of occurrences of each item. These are used for creating graphs of the data, which could be very useful for displaying this information to someone in a more readable format other than text files, and also displaying them to less technical people. And I saw this as an opportunity to make my project a tool which takes the data from a bulk extractor run and makes it more presentable, easier for someone to use, easier to present in general. So this brings me to the overview of my project. First and foremost, what I wanted with this project was a clean graphical presentation of data. Having a clean presentation of data makes a big difference when you're trying to pass information on to someone, particularly if they don't have a lot of experience in the subject matter. And I feel this tool really would give you the opportunity to do this. So unfortunately, just creating graphs of histogram files does not a project make. So the project developed into more of a wrapper for the bulk extractor class. So the second step was creating an easily navigable interface. So it's just a simple web app, simple interface. It just provides the user with the ability to use all of bulk extractor's functionalities without being forced to use the terminal. It just wraps everything up and makes it a much more easily usable piece of software. The final part of the project is creating a PDF report with graphics containing the histograms from point number 1. I wanted to have a PDF report just to present the data, not just in the web app form. Unfortunately, bulk extractor doesn't produce that much data that's easily presentable, that isn't just a list of text. So I stuck with the graphics for the PDF report. It's a series of histograms, same information as the website, but in PDF format. Brief overview of the environment I worked in. Used Python for this. Major libraries I used. Number one was ReportLab. That's the PDF creating software. Very powerful tool. Definitely the best in the biz for PDF creation. There's also FastKML and Flask Google Maps. These were used for representation of GPS data. If there is GPS data found on a disk image, bulk extractor creates KML files to gather the data. And I use these libraries for visualizing the data on the web app, which I will go into later. I use Flask as a framework for the project. Anyone who's familiar with Flask knows it's a great environment for small web apps, and of course HTML, CSS for the front end. So now I'll have a brief demo of the web app. So here is the home page. Let's run it first. Running on localhost. First piece of information we need is bulk extractor home directory to run some of the extra modules of bulk extractor. We need to know where they're located because they are Python files. So we get the home directory to begin with, stored as a session variable. So we open it up. We have two options. We can start a new run. We can open an old run. So start a new run. So I'm using the disk file from the homework, and it's called final test. So output file name, have to use absolute paths. HTML doesn't work well with relative. So let's run this. As you can see, it is waiting. If we check the terminal, we can see that it is currently running and is being outputted to the debugger. So it's done, and it presents us with the home page for the run. So we have 5 options. We can view the histograms, we can create the PDF report, we can run the post-processing programs, we can view all of the feature files as if in a file manager, and we can view the GPS data. So let's just start with the histograms. So what this does is parse the directory, the output directory of the run, and displays a button for each histogram file. And if you click on the button, it takes you to a graph. This one has no data. There were no credit cards found in this run, but let's open one that does have one. So domain, if you can see, creates a nice pie chart with all the information. This is a Google API, very easy to use. Check out some other ones. We have emails. These email addresses were found. Telephone, got a bunch of telephone numbers. URLs, same thing. So that is the graph. Then we have the report. Same information, but in PDF format. So here you can see we have one page for each graph. Same information as the website. Uses the report library to create everything. Went with this nice simple design. Just wanted to get this information in PDF format. It's really the only presentable information from the run. So the third option is running the post-processing programs. So we use one of these in the homework assignment, identify file names. There are 3, bulk diff, CDA tool, and identify file names. Bulk diff compares 2 different runs of bulk extractor. So you put in a directory path for a previous bulk extractor run, compares it to whichever one you currently have open in the app, and produces output and produces a text file that tells you what the differences are between the two. The CDA tool compares 2 runs as well using a special algorithm. It's listed on the website, on the wiki for bulk extractor. Again, get a directory path. And the final is the identify file names. This runs right from the current run. It produces annotated information. Just enter the directory name where you want to output the file, or the files. This is relative, so whatever path you enter, if I entered final test identify file names, they would show up right in the final test directory. So view all the feature files. This is basically just a file manager for the files. I wanted to make them viewable in the browser just so if you never want to leave the web app to view all the information, you don't have to, even if you are just viewing the files in their raw format. If we open them up, you can see simple. It's just a passed from Python to HTML and display right on the screen. Final option, view GPS data. This image has no GPS data. So what we'll do for this, I'm going to go back a bit and open up another run that I have. This is a run I ran on a file which specifically has KML data. This is actually on Bulk Extractor's GitHub page to let you test everything. So if you view GPS data here, you can see there are 2 KML files that were produced by the run. Click Get Map, and we get a map of all the information found in the run. So we have points that were created. I went with a far zoom because if you have points across the world, it's nice to be able to see all of them to begin with. If you click on them, the name comes up. This one didn't have a name in the disk image. These did have a name. Oops. I can see it's the varsity, which, upon some Googling, is a food joint. So someone was collecting data on this restaurant. So that is it for the web app. We'll just take a quick jaunt over to my code. Just go over some things. Anyone who's used Flask will recognize this. Pretty standard. We have session variables for the home directory of bulk extractor, for the output directory of the current run we just did, or just opened, so it holds on to that. Here's the home for histograms, so it checks the directory for all histogram files, and then submits that to the list that you saw in the web app. And then when you click a link in the list, it comes down and finds the proper function for that particular list. Now what else we got? We got post-processing. Each one has its own function. It's a sub-process call. Runs a system call. Python 3 for this. Needs Python 3. And here's the KML information. Again, this checks the directory, the KML directory for files. That's those radio buttons on the web app. Puts them up, and when then you submit, it creates points from the file name, and it creates a map from the points. And then pass that back up to HTML, and it produces the website, or web page rather. Here's the feature files. Just checks the directory. Anything in that directory is a feature file, other than non-txt files. That the PDF report is outputted to that directory, so I added that to avoid any errors. And then when you click on a file, it actually just reads the file from the directory and passes a string up, which is displayed. And then the report creation. Using Report Lab, we create a canvas, and we just draw these graphs right on the canvas. Yeah, that's it. So that's everything with the project. I hope you guys found this interesting. I hope everyone has a great summer. Thank you.